Happiness is understanding physics. Wonderful. But I've had a bit of flu. Anyway, this question in this video that we're going to look at is a little bit involving. Yeah, it's a little bit involving, but it's not difficult. I know that I'll explain in the way that you'll be able to understand, because happiness is understanding physics. The question says, a 15-kilogram mass fastened to the end of a steel wire of unstretched length 0.5 meter is whirled in a vertical circle with an angular velocity of 2 rev per second at the bottom of the circle. All right, so it's moving like that in a vertical, not horizontally, but in a vertical. The cross-section area of the wire is 0.02 square centimeter. Calculate the elongation of the wire when the weight is at the lowest point of the path. Steel has Young modulus 2 by 10 to the power 11 Pascal. All right, so this we have a system like this. Right, so this system is not moving in a horizontal, but it is moving in a vertical path. All right, I believe this at least. All right, it's moving in a vertical path like that. So I can pick that as the center, whereby we're going to say the radius of this path is equal to the unstretched length of the wire. All right, that's what we're going to get here. We'll do like that. And then we're told to say, we need to consider the elongation at this point at the bottom of the path. So here at this point. Now, at this point, what kind of motion do we have? And here in the wire, what kind of the force do we have? So we can say we have the force tension in the wire there. All right, we have the tension force in the wire, and then we also have what? We have also the weight of this mass, 15 kg. Now we have the weight of that, and then we have also motion in that vertical, or in this direction, we have the motion. And this motion is basically the centripetal motion here. All right, so now, let's look at what we have first. We have the mass, 15 kg. It's already in standard. We have cross-section area, 0.02 square centimeter. So this one has to be in square meter. Those are the standards we know. So we can divide that by 10,000 to get the in square meter, which is going to be 2 times 10 to the power -2 square meter. And then we have the angular velocity, which is 2 rev per second, which I would love us to convert it to rad per second. So how do we convert? We know that 1 rev is equivalent to 2 pi rad. So we are going to multiply that one by 2 pi rad, which is just 12.57 rad per second. What else do we have in this question? We also have Okay. We also have the length of this, right? So the length is 0.5 meters, and Young's modulus is 2 by 10 to the power 11 Pascal. All right, so I'm writing this because I think you've seen what I'm doing so that I have the data. All right, so we have that system that I've shown you there. All right, so now how do we go about it? So we know that Young's modulus is stress over strain. So this question is from mechanical properties of matter. All right, yeah, mechanical properties of matter. So we have Young's modulus being equal to stress over strain. And this stress is basically the force per given area. And the strain is basically the change in length over the original. So that is basically what we have. So now here, the force that we have on this system is the tension. So we need to know what tension is. Otherwise, we have the area, we have the Young's modulus, we have the length, and this is what we want. So the most critical thing here is to find the tension. So how do we get the tension? So looking at the forces there now, we are going to say that the summation of forces in the Y we have seen, they're giving us motion, which is centripetal acceleration there, right? So we are going to have tension minus the weight being given or giving us that. So tension is equal to M. Centripetal force, we know that is velocity over R plus mg plus mg, and we get the tension from there. Now, the velocity that we have been given here is the angular velocity or angular speed. So if we want, we can convert. Here we know that velocity is given by r that. So tension is going to be m. Let me factor out m, and then I'm going to have r squared omega squared over r plus g, which is going to be m, because r and r will go squared plus g. So that will give me the tension. So let's find the tension. So tension here is going to be mass 15 kg, and I have the radius 0.5 meters, and I have the angular speed 12.57 rad per second squared plus 9.8 meter per square second. So our tension is going to be right. So I'm getting tension as 133. Right, so let's do this. 0.5, 4.57. I'm getting 1332.04 Newton. So that will be the force that I'm going to use. So maybe from here, I can say that we can get the stress. So since stress is force over area, which happens to be tension over area, it's going to be 1332 232.04 Newton over area we've got to be 2 by 10 to the power negative 6 square meter. So the stress here is 2 by 10 power negative 6, right? So I get stress to be 666.020000 Newton per square meter. So that is our stress that we found. All right, so after getting stress, the whole lot of this, I think now we can go ahead to calculate we can go ahead and find delta L. So what we have is we're going to have that stress over changing L over L, which is going to be L times stress over changing L. So meaning that we're going to have change in L being equal to length times stress over Young's modulus. All right. So now we are going to have change in L being equal to L is 0.5 meters times stress, which is 6602000 Newton per square meter, over Young's modulus, which was 2 times 10 to the power 11 Pascal. We know that Pascal actually is Newton. We can convert it to Newton. It's actually Newton per square meter, Pascal, because it's force over area. So that is going to give us so it's giving us 1.66505 times 10 to the power negative 3. Okay. So this is going to be in meters. Right. So changing L, can give it like that, or you can say 1.66 either 5, and then 10 to the power negative 3 is a milli in prefix. If you remember prefix from the first topic that you do in physics, and also I think in chemistry, prefix. So we're going to have millimeters like that. So this is how you get to find this question. I believe it was easy for you to follow through, and just the way it was easy for you to follow through, it will be easy also for your colleague, your friend to follow through. So share with them the link, the YouTube channel name, and don't forget as well to give me reaction on this video. How did I do? That will give me the morale of doing more and more. Thank you so much for your time, guys.